You just watched Game 2 of the NBA playoffs. Some dude, some absolutely elite, 7-foot genetic miracle who trains 6 hours a day, grabbed his leg, fell down, rolled around on the floor like a golden retriever who sat on a bee. The announcer goes, severe cramping, and millions of Americans watching at home go, this guy runs 50 miles a week. He has a personal chef. He sleeps in a hyperbaric chamber. And he got taken down by his own leg? What is actually happening inside a muscle when it burns? Why does it hurt like that? And why can an NBA player, a peak human specimen, cramp out in Game 7? I'm Hammy, and today we're going inside your muscles. It's going to be gross. It's going to be fascinating. And you will not look at leg day the same way again. Part 1, what even is a muscle? Okay, quick level set before we get into the chaos. Your body has about 600 muscles. They make up roughly 40% of your body weight. Everything you do, blinking, breathing, screaming at the TV when your team blows a fourth quarter lead, that's all muscles. A muscle is basically a big bundle of fibers, like a cable, but alive and full of opinions. Each fiber is made of smaller fibers. Those are made of even smaller fibers. And at the very bottom, the tiniest level, it's just 2 proteins, actin and myosin. That's it, 2 proteins. That's the whole show. When your brain says move, a signal shoots down a nerve, hits the muscle fiber, and those 2 proteins do this thing that is genuinely kind of beautiful. Myosin reaches out, grabs actin like a tiny hand, pulls it, lets go, grabs again, pulls again, millions of times per second. Your muscle shortens, you move. It's like 1,000 tiny workers pulling a rope all at once, in perfect sync every time you move literally anything. That's how you lift a fork. That's how LeBron drives to the basket. Same basic mechanism, just different scale. Cool. So where does the fire come in? And also, why does it stop? Because it does stop. You slow down, you catch your breath, the burn fades. That's your body clearing the hydrogen ions, restoring pH, getting back to normal. The whole system resets, ready to do it again, which is kind of incredible when you think about it. Your cells just went through chemical chaos, self-corrected, and are now sitting there like nothing happened, waiting for the next sprint. Part 2, the burning. Why? To do all that pulling, your muscles need energy. That energy comes from a molecule called ATP, adenosine triphosphate. Don't worry about the name, just think of it as your body's fuel currency. Every biological process runs on ATP. You always have some ATP on hand, but not a lot. A few seconds worth at rest maybe. So when you start exercising hard, sprinting, jumping, trying to stop Anthony Edwards coming off a screen at full speed, your body burns through its ATP supply almost instantly. Then it needs more. Right now. Fast. Option 1, use oxygen. Your body grabs glucose, runs it through a long and efficient process using oxygen, and gets a ton of ATP out. Clean, sustainable, great for a jog. Not so great when the shot clock is at 2 and you need to explode. Option 2, skip the oxygen entirely. Go anaerobic. This is where it gets interesting. When your muscles are working harder than your lungs and heart can keep up with, when demand outpaces oxygen delivery, your cells switch to a faster, dirtier process. They break down glucose without oxygen. It's quick, it's powerful, it keeps you going. The byproduct, lactate and hydrogen ions. And here's where it gets real. Those hydrogen ions flood into the muscle fiber. They interfere with the actin-myosin pull. They change the internal pH of the cell. The muscle gets less efficient, slower. The force drops. Things start to go wrong. That acidic buildup inside the fiber, that's the burn. That's the thing you feel. You know the feeling. Your lungs are fine. Your heart is fine. But your legs are just screaming at you like a smoke alarm going off in a room where nothing is on fire. That's your muscles telling you. We have entered the no oxygen zone and things are getting weird down here. Now, here's a twist most people don't know. For years, coaches and trainers blamed this on lactic acid. You've got lactic acid buildup. That's the burn. You need to flush out the lactic acid. Sports coaches built entire training programs around this idea. It was everywhere. Turns out, not quite right. Lactate itself is mostly fine. Your body actually uses it as additional fuel. It's the hydrogen ions doing the damage, not the lactate. But lactic acid buildup sounded cool and scientific, so it stuck around for decades. Science is a process. It revises. It catches up to itself. Eventually. Part 3, the cramp, the actual horror. Okay, so we've got the burn sorted. That's hydrogen ions. That's metabolic fatigue, normal, expected. But what about the cramp? That sudden, involuntary, make you collapse in front of 20,000 people muscle contraction? What is that? Here's the wild thing. Scientists still do not fully agree on why cramps happen. Yes, we sent people to the moon. We sequenced the human genome. We have a sports car floating in outer space. And we still don't have a complete agreed-upon explanation for why your calf seizes up in the fourth quarter of a playoff game. Science. It's a process. The old theory, dehydration and electrolytes. You sweat. You lose sodium, potassium, magnesium. These minerals help nerves fire properly. Without them, you get chaos. Misfires, cramps. This made sense. This is why sports drinks exist. This is why trainers tape bananas to the bench like they're prepping for a potassium emergency. Totally reasonable theory. But here's the problem. Plenty of cramps happen in well-hydrated athletes, in cold weather, early in games, before anyone has had a chance to sweat much. Athletes with perfect electrolyte levels still cramp. The dehydration theory doesn't explain all of it. The newer theory, neuromuscular fatigue. Your muscles and your nervous system have a constant feedback loop running. There are sensors inside your muscles called muscle spindles and Golgi tendon organs. They monitor tension. They monitor stretch. They send signals to your spinal cord saying, too much tension, ease up. Or stretch detected, contract. When you're exhausted, like fourth quarter of a Game 7 exhausted, every fiber already fired 300 times more than in a regular game, that feedback system starts to break down. The stop contracting signals weaken. The keep contracting signals stay strong. Your muscle gets stuck in the on position. It can't release. It just keeps firing. That's a cramp. Think of it like a software bug. The muscle is waiting for the off command. The off command got corrupted somewhere in the chain, so the muscle keeps running. Blue screen, cramp. And here's the part that should put things in perspective. This can happen to anyone. It doesn't matter if you're a 6'7" specimen who runs a 35-inch vertical and can bench press a small car. If you push past your conditioning, if you ask your muscles to do more than they have been trained to handle, the system breaks down. The NBA player who cramps in Game 7 is not weak. He is operating at a threshold most humans will never come close to touching. He just crossed his own line. Everyone has one. And there's something kind of equalizing about that. The mechanism doesn't care about your salary, doesn't care about your training staff or your recovery pod or your six-figure diet plan. Push past the threshold your nervous system was prepared for, and the system fails. Every time. For everyone. Part 4. Why does soreness hit you the next day? One more thing, because this one is personal to basically everyone who has ever exercised. You work out Monday, you feel pretty good Monday night. You go to bed thinking, okay, maybe that wasn't so bad. You wake up Tuesday morning and your legs have been replaced with concrete. You try to go downstairs and your body just files a formal complaint. Why? You felt fine. And now suddenly it's Tuesday and everything hurts? This is called DOMS, delayed onset muscle soreness. And for a long time, people blamed it on the lactic acid thing again. It's buildup. Stretch it out. You need to foam roll. Wrong, wrong, and also wrong. Here's what actually happens. When you exercise, especially new exercises or movements where the muscle lengthens under load, like going downstairs or lowering a weight slowly, you create tiny tears in the muscle fibers. Microdamage. Controlled, intentional, beneficial microdamage that is part of how your body adapts. Your immune system responds. It sends in inflammatory molecules. It starts the repair process, but that inflammatory response takes time to ramp up, 24 to 48 hours. So, Monday night, fine. Tuesday morning, your body has decided to throw a full inflammation party inside your quads. The nerve endings in the muscle detect pressure and swelling and chemical irritants. That is the soreness. That is what you feel. Not damage you should panic about. Your body is doing exactly what it's supposed to do. The construction crew showed up. They are fixing things. Things feel worse before they feel better. And when the repairs are done, when the fibers finish rebuilding, they come back slightly thicker, slightly denser, better adapted to that specific load. That's what muscle growth is. You break it a little, your body overbuilds, you end up stronger. You get better by breaking yourself a little. On purpose. Repeatedly. The human body is wild. Part 5. So, what's the fix? Okay, you're an NBA player. You're cramping in Game 7. 30 million people are watching. The score is tied with 2 minutes left. What do you actually do? Stretching. The trainer grabs your foot and pushes your toes up toward your shin. This manually activates the Golgi tendon organ, the sensor that sends the stop contracting signal. It's essentially forcing the off command through manually. It works. It looks ridiculous, but it works. And then there's pickle juice. I know. But hear me out. Research has found that drinking pickle brine can stop a cramp in about 30 to 45 seconds, which is way too fast to be about electrolytes. Your bloodstream can't even absorb anything that quickly. So what's happening? Current theory, The strong acidic taste of the vinegar triggers receptors in your mouth, throat, and stomach. Those receptors send signals up to your spinal cord through specific nerve pathways. And somehow, and scientists are still figuring out exactly how, that interrupts the cramp reflex at the neurological level, before the electrolytes even matter, before anything gets absorbed. An elite athlete in a playoff game, drinking pickle juice, because of mouth receptors and spinal cord reflexes. That's where the science took us. Honestly, I respect it. But the real answer, the one that actually prevents cramps long-term, is conditioning. Your neuromuscular system needs to be trained at the intensity you intend to compete at. The more your nerves and muscles have practiced a specific workload, the less likely the feedback system falls apart under pressure. Electrolytes help. Hydration helps. Sleep helps. Everything your coach told you is real. Just maybe not for exactly the reasons they said. Final. The open question. Here's what gets me when I think about all of this. Your muscles are doing this insane, coordinated molecular choreography every single moment you move. Millions of protein interactions per second. A feedback loop between your nerves and your spinal cord running in the background constantly. Inflammatory repair crews showing up overnight and rebuilding you slightly stronger than you were before. And you don't think about any of it. You just stand up and walk to the kitchen and your 600 muscles figure it out. No input required. Until they don't. And then one of the best athletes on the planet, a person who has dedicated their entire life to making their body work, collapses in front of 20,000 people because two proteins couldn't get the stop signal. The burn is hydrogen ions. The cramp is a corrupted off command. The soreness is a construction crew. The solution to cramps apparently involves pickle juice. None of that changes the fact that it feels absolutely terrible when it happens to you. But here's what I keep coming back to. You have been running this system your entire life. Every step, every breath, every time you reached for something. 600 muscles, trillions of protein interactions, a nervous system sending and receiving thousands of signals per second. And you never once had to think about any of it. That is the thing. The body does not ask for your opinion. It just goes. Quietly, efficiently, unbelievably, until the moment it doesn't. And even then, even in that cramp, even in that soreness, even in that burn, it is still trying to fix itself, still adapting, still working to come back stronger. Your body is a miracle, an incredibly complainy, dramatic miracle, but a miracle. I'm Hammy. Subscribe if this made you flex something just to check if it still works, and watch this next.